They call it Enceladus, a frozen moon orbiting Saturn, a globe of ice more than 150,000 miles wide, shimmering in the ring's shadows. For decades, scientists considered it inert. A frigid world, far too cold for life as we know it. But what if that assumption was wrong? What if, under that miles-thick crust of ice, something stirs? Something alive, something that has remained hidden. But now, new data from 2025 suggests that beneath those icy tiger stripes, Enceladus might be hosting something more than chemistry. A heat signature, geysers, hydrothermal conditions, and a radio silence from NASA that raises more questions than answers. This is the story of a moon that shouldn't be alive, yet might be hiding a secret ecosystem under its frozen shell. The Cassini discoveries, first clues from the ice. Let's rewind. Between 2005 and 2017, NASA's Cassini spacecraft orbited Saturn and deployed daring dives through geysers on Enceladus's south pole, through cracks called the tiger stripes. It collected plumes, vapor, ice particles, salt grains, spewing from fissures in the ice crust. Cassini's instruments detected water vapor mixed with tiny ice grains, salts, silica particles, and carbon dioxide. But one of the most provocative results, the spectrometers picked up organic molecules, simple hydrocarbons, the building blocks of life. That meant this moon wasn't just an icy rock. It was active. It was spilling its interior into space. By 2015, scientists had enough evidence to strongly suspect that beneath the ice lay a liquid ocean, warmed from below by tidal friction and perhaps radioactive decay. A hidden sea, floating under 20 to 30 kilometers of icy shell. That in itself would make Enceladus one of the prime candidates in the solar system for life. The 2025 breakthrough, new spectra, stronger evidence. But here's where things shift from interesting to game-changing. In 2025, a new paper based on reanalyzed Cassini data and archival telescope observations revealed spectral lines previously dismissed or masked. They found methane, CH4, hydrogen, H2, ammonia, NH3, and complex organics, possibly polycyclic aromatic hydrocarbons. These are molecules associated not just with passive chemistry, but active hydrothermal processes, where hot water from below meets rock, generating energy and chemical gradients. On Earth, hydrothermal vent ecosystems, deep on the seafloor, host life entirely independent of sunlight, fed by these kinds of energy gradients. So if Enceladus has similar conditions, the possibility arises life could exist there in the dark, sustained by chemistry alone. Even more, the study found a localized heat anomaly in one region of the southern polar basin, a hotspot in thermal maps that didn't match expected models from tidal heating alone. It's a spot that glows faintly warmer than its surroundings, kind of like a heartbeat under the ice. And yet, NASA has remained almost eerily quiet about it in public. Between 2019 and 2025, despite mounting evidence, NASA made no major announcements about Enceladus's habitability. No press conferences, no flagship missions, just occasional academic papers quietly published and internal planning documents that never left the controlled channels. Why? Some argue caution. In astrobiology, claims must be ironclad before going public. Others whisper something darker. What if NASA saw something in the data they didn't want us to broadcast? Remember, in late 2017, Cassini ended its mission by plunging into Saturn's atmosphere. One publicly stated reason: to avoid contaminating moons like Enceladus with terrestrial microbes. But could that final dive also have been convenient? Some suggest perhaps Cassini detected something alive, or something anomalous, in those final passes. If that were the case, pulling the plug and ending with silence would prevent the spread of data too volatile or too dangerous. Again, these are hypotheses, but that silence, over half a decade, stands out. Because in science, silence is rarely neutral. The case for symbiotic life. Under the ice, let's explore the possibility. What life might look like on Enceladus. If energy and organics exist, then microbial ecosystems could thrive, but under extreme constraints. Life in darkness would rely not on sunlight but on chemosynthesis like Earth's vent microbes, which oxidize hydrogen or sulfur to power metabolism. These hypothetical organisms would be symbiotic with rock strata, living in pores of rock under the ice-ocean boundary, feeding on chemical disequilibrium. They'd release methane, hydrogen, or ammonia as byproducts, exactly what the 2025 spectral data suggests. A single cell could use that energy gradient to sustain itself, reproduce, perhaps form biofilms clinging to mineral surfaces. But could it evolve complexity? Over billions of years under stable conditions, maybe. Could multicellular life emerge? That's speculative, but not impossible in a steady, isolated environment. If you imagine a subterranean ecosystem slowly growing, evolving, perhaps even up to microscopic worms or simple animals, all hidden beneath ice, unknown to us, that's the sort of scenario the new data hints is possible. And if a hot spot exists, a region of extra heat, that could act as a thermal vent hub, like volcanoes on Earth. Before we get too excited, let's examine the skeptics. Some scientists caution, methane and hydrogen can be produced abiotically via serpentinization, water reacting with rock. Organics can be primordial, trapped in the ice shell. Thermal anomalies can come from localized fractures, friction, shear heating, nothing biological. And the heat signature might simply be model error or data artifact. In astrobiology, extraordinary claims demand extraordinary evidence. We lack a lander on Enceladus right now. So yes, the biological hypothesis is speculative. But it's no longer fantasy, it's now a viable contender. What if Cassini saw too much? Let's consider a more provocative scenario, not proven, but carefully reasoned. Suppose Cassini's final dives over Enceladus captured traces of life, perhaps microscopic biosignatures, in the plume data that were later deemed inconclusive or ambiguous. Instead of announcing prematurely and inviting extraordinary scrutiny, NASA might have chosen silence, more data, more caution, more internal review. When a mission ends by crashing into Saturn, it also closes the door on further revelations. What if the mission termination was partly to cover up data anomalies, to avoid contamination or cross-contamination of Earth microbes, but also to stop new data leaks? If that seems conspiratorial, remember, internal mission logs and unpublished anomalies often reveal far more than public press releases. We don't know what Cassini saw in those last passes. We only know somebody thought finality safer. The longevity of hidden life, and the alien question. Here's where things go cosmic. If life is beneath that ice, isolated for perhaps billions of years, it would represent a truly alien ecosystem. It wouldn't look like Earth life, but it might have the same essential chemistry: proteins, lipids, nucleic acids, derivatives of carbon, water, energy gradients. And if one moon in our solar system has developed life independently, what does that imply for the rest of the galaxy? If snowball planets, icy moons, deep ocean moons can support life, life might be abundant. What if this hidden ecosystem is aware, not in the human sense, but in extremophile communication networks and detecting our probes? What if it has evolved defenses, silent boundaries, biochemical shields? The heat anomaly might mark a region of metabolic activity, perhaps a colony or a vent hub. If that's true, our flybys and plumes could be like shining flashlights into a hidden cave, waking creatures we don't know. Could these hypothetical life forms detect Cassini's passes and respond in kind in atmosphere chemistry shifts, turbulence in the plume, or subtle mobilization under the ice? We don't have proof, but such speculation is no longer far-fetched when the data allows it. The future, missions, dangers, contact, what comes next? Scientists have proposed missions like Enceladus Life Finder, ELF, or Ocean World's Lander, designed to sample plume particles, map heat flux, and eventually break the ice shell. If we launch a lander or sample return mission, we risk contamination in both directions. We might contaminate the ecosystem, or bring unexpected biology back. That's why NASA and ESA guard mission parameters tightly. But public pressure grows. Fans, researchers, dreamers want answers. Imagine the moment we find RNA fragments or metabolic signatures in a plume sample. That would be confirmation, not just of life, but of a second genesis in our solar system. It would rank among the greatest discoveries in history. But we must be scientific, cautious, and clear about what we know and what we hypothesize. Closing, the moon that shouldn't be alive, 2 decades of Cassini data. Heat signatures under ice. A moon that by rights should be dead and frozen, but might instead be a dark ocean world with life under its shell. NASA's silence is not proof, but it's a silence we should question. Cassini's final crash wasn't just mission end, maybe it was a closing book. Now the question remains, if Enceladus is alive, what does that mean for us? Are we alone? Or is life hiding in the dark under the ice of Saturn's moon, waiting for the day we break through? Only one thing is certain. The next mission to Enceladus will be one of the most consequential in human history. We are not just exploring a moon. We might be approaching a mirror. A window into what life can become, in the cold, in the hidden, in silence. And if that life is listening, then when we knock on the ice, it might knock back.